Okay, in this video we will demonstrate the rigid body tutorial. We'll build it up from scratch. Let's first look at the input file. And we'll see from this that what we have is a structural node, a rigid body, and a force. And the structural node, we see it is at the origin, and it has an initial velocity of 0, 1, 0 and no initial angular velocity. Well, in the Blender and MBDyn environment, initial velocities and initial angular velocities are intended to be provided for exclusively through the use of reference frames. Otherwise, every object is starts off static in the global reference frame. So we'll take that approach here, and then we'll see here's the body. It has a mass of 1, which is in the at the origin with no rotation matrix, and it's also subjected to an absolute force of minus 9.81 in the z direction. So we'll add that. So let's start with the body. We'll give it a initial velocity, and then we'll add this force. So to do that, we come over to Blender, and we start by, I'll do a Shift A to add. We'll call it a cube. Actually, we probably want to give it a name, so we'll come over here and we'll change its name, and we'll change its name to body, right? So now we have a body, and we'll add the body here, all right? And this body, it has a mass of 1. As kind of a helper, we provide the ability to provide the location here, but it's a lot easier to use the Blender native I/O facility. So there's the body, and then we'll add a reference frame. So we'll add this frame, all right, which will also create another cube, all right, and we'll call this reference, all right. Now reference will have this body in it. So I'll click the body, then Shift, and then click the reference frame, and now we add a frame. Now this reference frame, initially it has these two as its linear velocity and its angular velocity. But what we'll notice here is that it's pointed, the reference frame is pointed, the z direction is vertical. We want it to have an initial velocity in the y, and I always like to just have everything referenced oriented to the z of the reference frame. So I'll rotate this, and I press Control so I can click this thing through to 90 degrees, and then boom, so I'm at 90 degrees. So now this reference frame is pointed in the y direction, and now I'll add a matrix. Actually, I'll add a new 3x1 matrix, which I'll call it, it's going to be have 0, 0, 1 as its values, so that we can rename it and call it a 3x1 where z is equal to 1, right? So now that's our reference frame now, I mean the vector we'd like to have in the reference frame. So let's go back to the reference frame and edit this. And we have now the linear velocity. We want to make this unit vector in the z direction. And if we look at our other one, which is our angular velocity, we're looking at that now. That's 0, 0, 0. So that's what we want. So now we have a body. It's in this frame. And if we were to animate it, which is really nice with this graphical environment, you can step by step build up the model, then animate it, test it, make sure it's doing what you intend for it to do. All right, so we can animate this. We created the simulation, we run the simulation, and then we animate the objects. Let's say animate every 100 steps. Now what we should see, let's see, is that this body will just move at 1 meter per second to the right. Let's see here, what's going on here. Let's see here. We've got this, we've got this our body, and this is our, let's make sure okay, we've got a reference frame. The issue is that the body is not in the frame. So let's get rid of the frame first, and let's do this again. Alright, so we'll make this frame, reference frame. It's got the, again, there we go, linear velocity, okay, do the initial value, run the simulation. and animate the objects, and let's see what happens. Ah, there we go. Okay, so that's what we want. So its initial velocity is 1 meter per second in the y direction. See, interactive is nice because you can check to see step by step that the model is doing what you intend. So next, we want to create a simulated gravity force, and in this example it's done through an absolute force attached to that same node. So we'll go here to that same node, and now we'll do Shift A to add a new mesh. We'll call that a cube. Now we'll give this one a name. This one will be our, well, it's going to be the force. Let's just call it the force then, right? Now, why was that the, oh, the reason it's force 01 is because I have force in another, anyway, so that's force 01, that's fine, that's no big deal. We have the word force used in another scene. As you can see, I have other scenes here. But we'll stick with that. So we've got force. Now, what that will do, we'll take the, click on the body, and then click on this new object with Shift depressed, which is going to be our force. And we will make this a rigid offset. And that simply is either a rotational offset or a distance offset from whatever it's connected to. In this case, we didn't need to do it because we want to have the force in the z direction, but at least you can see how that's done. So now this rigid offset, we will add a force to it, and the force it will add is this, it'll be a structural force, it'll be an absolute force, and right now the only drives we have are the meter drive for the simulation unit drive. So we'll need to create another drive, which will be the constant drive of minus 9.8. So we'll come over here to drives, we'll add a constant drive of minus 9.8, and then we can go back to our structural force, edit it, and select that. So we now have our constant drive. And if we click on this, we'll be able to edit that constant drive. We look at it, and sure enough, there's the 9.8. Now, when we simulate, what we should see is the initial velocity of 1 meter per second and the force absolute of minus 9.8 in the positive z direction. So we'll click on initial value, which will create our new input file, and we'll run the simulation and then animate it. And let's see if this happened. There we go. So it's exactly what we want to see. And if we'd like to watch the object in terms of its, let's say its plots, we can plot the output, and we can get the force in the x, y, and z directions. There we go. So that's at minus 9.8 right there. And then if we want to look at the velocities, we can look at the velocities in the x, y, and z. We really don't need the x because we're only operating in y and z. And there we go. That's pretty much what you'd expect, right? So the z, it's doing this, and oh, these are the positions, right? So this is the z is going like this, and then this the x is just going that way. So and you know, we can do the same thing for the body. We can look at let's see here, the body. Look at, oh, there's really nothing to plot on the body, but we can plot the node, right? On the node we have x, y, and z, as well as all the other various values that are available. But so we'll just leave it at that for now and wrap up this video. Before I do, I'll just show the input file, right? So earlier we had mentioned that the input files will be under examples. In this case, our scene is called scene. So the files will all begin with the name scene, and we can look at MBD and see how this compares to what we were modeling. All right, so that's what we were modeling. This is what we have, and we'll see that This is all descriptive up here, showing that we have a reference frame, whereas this one doesn't. We have a body, 3 drives, and 3 elements. And then the reference frame, this is where we pick up that 1 meter per second in the y direction, which is similar to in the node here we have the 1 meter per second in the y direction. And then the node here is basically 0, 0, 0, 0. So between these two we get this node. And then as far as the elements, we have a body which has a mass of 1 with a 0 displacement relative to the node and 0 angular displacement. And then the force is an absolute force, which is also connected to the same, I think, same node. Yes, to the same node. And its orientation is, well, it's in the z direction with this vector 0, 0, 1 with a value of minus 9.8, which is the same as what we have here, essentially. So that's how a example is done, and we'll do some more sophisticated ones later. All right.